In the previous video, we were trying to use this Docker file to build a container image and push it on the repository which we created on Amazon Elastic Container Registry. Our repository name was LangChain Streamlit. So now the image has been pushed. I believe like that it has also been pushed for you guys. So if not, please watch this video after you have are completed pushing the image. So moving on, if we move to our repository, that is LangChain Streamlit, if we click on this, we see that initially it was empty, but now since the image has pushed, we can take a quick glance at the metadata here. The artifact type is in fact an image which confirms it's a Docker image. It displays the time and the date the image was pushed. And more importantly, we now know the size of the Docker image. It's very important to understand that Docker container sizes are all basically give a signal towards your deployment strategy. If the container image size is pretty high, we need to make sure that the overall inference latency becomes lower. So let's say if we are supposed to work with transformer based models in NLP, those models are pretty heavy in size. And once we containerize our application, which would load our model weights, let's say if we go back to this folder, let's say if we have another folder called models, and if we were to load our model weights from that particular folder, the time it takes to load the models, the time it takes for the loaded model to process user-based text, pass it into the encoder decoder, compute position and sign based positional embeddings and word like sentence level embeddings, and ultimately return the response back to the user. That response could either be, let's say, a label for user a given text, that is a text classification problem, or just like in our case, it's a summary of the user given text. So the time it takes for a user to send the text, for the model to load the weights, process the text, and return it back to the user, all that comes under inference latency. And our job as ML engineers is to reduce inference latency. If heavier Docker images, if we have a heavier Docker image, it would definitely take more computational power, as well as we need a heavy infrastructure to make sure that the overall like Docker image is supported on our infrastructure, and we need to assign memory and compute power accordingly. But for in our case, like since the model image size is roughly 476 MB, like we don't need a very heavy infrastructure for this, and that is because most of the heavy lifting, that is loading the model weights, computing our embeddings for our sentences, like whatever sentence we are passing to the model, is being done by OpenAI, and all we are doing is basically loading, like referring to the API given by OpenAI by making use of the key stored in secrets manager. So that is why our Docker image is lesser, and the infrastructure which we will be using will not be too heavy, or it won't be heavy in this case. So I'll talk more about that, the infrastructure part, when we come to the stage of deploying it on Elastic Container Service. The next important part is the image URI. This again is a path to the container image. We can't just directly download this. We have to refer to this container image using the image URI part. So that is how we'll access it, and I'll show you how to use it in your ECS tasks when we come to that part, when in the subsequent lecture. So now we need to run the image, and I'll walk you through how to run your container image and the challenges which you will see, and then we'll try to understand why those challenges come up and how you can resolve them. So just go back to our terminal. Let me clear this out. We see that Docker, if we basically, if we need to run the image, all we need to type is Docker run, and then -p. We need to specify a port which this particular container image is supposed to use on my local system. So let's say I'm going to assign the port number 8501, and we need to use the port which the Docker container image is running on. That is the application, is the port number which the application is using inside the Docker container. So that is port number 8501. That is this one. So in this case, like both the port numbers are the same. The one on the left is the port number which this particular Docker container would use on my system. So this can change. It could be 8502, it could be anything. But this 8501 is the port number which the application inside the Docker container is going to use. So that is static, that cannot change. So it would be 8501. Then follow that by space. So our application was LangChain Streamlit. Let's just go back and confirm this. LangChain underscore Streamlit. So Streamlit and followed by the tag of the application. So once we do that, we press enter, let it run. So we can see that now you can view your Streamlit app in browser. Just copy this, go back to a browser and paste this really quick. We can see that we have the application here, but the application displays an unable to locate credentials error. Now, I want you to think about it for a second, like why that happens. So the reason why that happens is because when we initially ran our application, that is app.py, as in the terminal, it made use of Amazon like AWS CLI, which we installed previously, and made use of the secrets manager to fetch our API from the secrets manager and feed that into the model. That is exactly what's happening here. That is, we call the get secret. This get secret is run based on AWS CLI, which makes an attempt to fetch those secrets from our AWS account using the internet, and we were able to run it. However, when we containerize this application, that is, we install all the required dependencies which we need to run this particular application and like make an enclosed system, that is a standalone application. And when we try to run it, even though we see that we have a UI here which uses Streamlit, and initially the status here was running. So if I do a refresh, you can see that the status here was running, but now it's not running anymore. It's only displaying an unable to locate credentials. And that is because once we containerize our application, it no longer has access to AWS CLI. So it cannot make a connection to our AWS account and using our credentials, that is my access key and my secret access key, it cannot make a connection to my AWS account and fetch those like API secrets from the secrets manager. So a solution to this problem could be, if you want to run this application locally, you could pass an environment variable, that is -e, your AWS account key and a secret access key, to your Docker run command, that is Docker run. Then -e access key would be your whatever credentials you have set, and secret access key. But since we want to run this application on the cloud itself, in the next video, what I'll be showing you now is how you can get rid of this error by making a role, like by creating a new role under your IAM and attaching specific policies to that role so that your Docker container could fetch those secrets from the secrets manager, inject those secrets into your application, and make a call to the LLM. That is a large language model, and basically return a response back to the user. So I'll see you in the next video. Just make sure that you close this like Docker container by pressing Control-C. So let's go back to the terminal and press Control-C. So this Docker container has stopped. Otherwise, your port number 8501 would still be used. And for any other apps which might want to use the same port, it will throw an error. Okay, so now I'll see you in the next video now.